questions, I would like to provide a short summary about classification and prediction, including numerical prediction. For a classification task to be successful, or similarly for numerical prediction, the most important thing you need to have is the right set of attributes. Like when you're doing statistical analysis, your independent variables should be able to predict the dependent variables. If you don't have those good attributes, your classification problem will just not, or numerical prediction problem just cannot be successfully resolved. The second thing, once you have the good attributes, you want to tune your model, like we have shown earlier. Any model off the shelf may not be the best fit for your situation. A lot of times we test out different models. We might try a support vector machine. We might try random forest. In general, when you use the one type of algorithm, for example, if you use support vector machines, there are many different implementations of support vector machines, and some of them has different features added. A lot of times, those group of similarly constructed methods often give you fairly similar results. So you will test different types, for example, using like Bayesian, which is statistic-based, versus support vector machine, versus random forest. You try those out and find a promising approach, and you start to tune those. So we already talked about two important characteristics that contributes to a successful prediction task. The third one is the number of training examples. In majority of the prediction task that is not based on database, that's not set off from huge databases, small set of training examples is often the problem. That is why we talked about the, how to do semi-supervised learning and how to oversampling and undersampling to make the situation less severe for a prediction task. In database world, when we talk about data mining, we often have plenty of training examples. And those can also be a problem that we don't have enough of the computational power to process all the training examples. And we, for those tasks, we will have to use undersampling methods to actually reduce. We want to representative training examples that predict a good model, but we don't want to look at every of those examples. So I think that's a short summary.